Okay, in this question we are given a diagram of the situation. There's no words or no narrative with this question, but you're trying to find the velocity of the cannon. So basically what we have is we have a situation where we have before the cannon is fired and we have after the cannon is fired. So we know that's going to be conservation of momentum. So we say before the cannon is fired, we consider the cannon and the cannonball to be the same object because the cannonball is inside the cannon. So really, before the explosion, I have one object. After the explosion, I have two objects. I have the cannonball and I have the cannon. I'm going to say that the PC stands for the cannon, and I'm going to say the PB stands for the ball. So we have the cannon and the ball. So those are the information we have. So we have the initial momentum, or we'll go ahead and call it the total momentum just so we can keep it straight, is equal to the momentum of the cannon plus the momentum of the ball. Now, what we had before is we had a total mass and a total velocity. We have the mass of the cannon, we have the velocity of the cannon, we have the mass of the ball, we have the velocity of the ball. So now let's look at the information we have. If we have the cannonball as a mass of 10 and the cannon has a mass of 1,000, we could say that the total mass is 1,010 because you have a total mass, you put the ball inside the cannon, that's what you have as 1,010. Now, it doesn't explicitly say so, but we can assume that the velocity of the cannon is originally 0. It doesn't make a whole lot of sense to kind of wheel the cannon forward and have it shoot backwards. So in order to get the best aim, we're going to assume that this value is 0. Now, we also have that the mass of the cannon tells us is 1,000. We have the velocity of the cannon, and that's what we're trying to solve for. Now, one key thing that you want to look at is it actually has the arrow going backward. Okay, that is an indication that I should get a negative value here whenever I do all the math. Plus the mass of the ball times the velocity of the ball. When you take all these things, you multiply them out. Anything times 0 is 0. You have 1,000 VC plus 5,000. Now, in order to solve this, you need to take this and you need to move it to the other side. When you do that, you get negative 5,000 equals 1,000 VC. Divide both sides by 1,000, and what you get is the velocity of the cannon ends up being negative 5 meters per second. Now, a lot of people get stuck on this. They say, well, how can the cannon be going negative 5 meters per second? Remember, with velocity, the negative is just an indication of direction. If the cannonball is fired at a positive 500, we would expect the cannon to go in the opposite direction at a much smaller velocity, which it does.